Hey everyone, in today's video I'll be talking about quadratic application, and with some of these questions they can be a nuisance as they're hard to visualize, but I'll go through step by step on a couple of styles of quadratic application, and then I have an example at the end for you to do. And that's it, and let's get started. So, with our first example question, again, I've said in many of my videos, it's good to break down the question and then see what you have to solve for, right? So, a football is thrown in the air. Its height above the ground is approximated by height equals 2 plus 14.7t minus 4.9t squared, where h is the height in meters and t is time in seconds. Determine the height of the ball after 2 seconds. So let's see what we are given. So we know the ball has been thrown in the air, right? And it's given in the form h equals 2 plus 14.7t minus 4.9t squared. And we can see that this formula that I highlighted is to the power of 2. And so we know it's definitely quadratic, but right now it's not in the form of y equals ax squared plus bx plus c. But if we were to rearrange it into that form, it would be h equals negative 4.9t squared plus 14.7t plus 2. All right, you might be wondering, why would I have to arrange it in the quadratic equation? Why would I have to model it into ax squared plus bx plus c? Well, in this specific question where it says determine the height of the ball after 2 seconds, you don't really need to. But in B, in part B of the question, when does the ball touch the ground? This form that I put into ax squared plus bx plus c will be very helpful, and I'll explain that later. But let's first answer 1a. So we know t equals seconds, and we know h equals height. Wow, I cannot spell height. And the question wants us to figure out what is the height of the football after 2 seconds. So what you would have to do is just substitute into t. So it would look like this. Let me fill that in. H equals negative 4.9, and then you're gonna be left with since we have to substitute 2 as t, it's just gonna be 2 squared minus 14.72 plus 2, like that. And like I said, the reason you just substitute in it because it's just giving us the time, which is 2 seconds, and it wants us to figure out the height. So if we know the variable for seconds is t, all you have to do is substitute in 2 seconds, so then you get an output value, which is your height. It's not that complicated, this question. So now if we do simplify it, right, I mean, I'm going to use my calculator. I can't do this in my head. You are left with 11.8. So now, if you write a therefore statement, therefore, after 2 seconds, the ball will be 11.8 meters, because remember, height is represented in meters. The ball will be 11.8 meters in the air. And that's it for that question. Now, if we do the next part, or, well, not question, sorry, my bad. For the next part, it's asking, when does the ball touch the ground? So, think about it. If I were to draw a diagram, right? This is, for example, your axis, right? Because remember, this is quadratic after all. They're giving us a quadratic equation, and we have to use it to figure out when does the ball touch the ground. So we know that it's gonna look something like this, right? Oh wow, that's bad. Give me a second. Let me do it again. It's gonna look something like that. Okay, it's not drawn to scale at all, but based off the equation, that's kind of what it's gonna look like. Because remember, if we have h equals negative 4.9 t squared plus 14.7 t plus 2, we know that the y-intercept, right? This y, that's too much. This y-intercept will be right here. And we also know that there will be a reflection over the x-axis due to this minus sign. So then our graph will look something like that, right? And so now it's asking, when does the ball touch the ground? Well, a parabola, as we can see, just keeps going and going. I mean, technically, we throw a ball, like pretend this is a person right here. This is a person, right? The reason the y-intercept's at 2 is because when you throw the ball, it's not automatically coming from the ground. It's coming from where the person's throwing it, right? So it's already up in the air. So when you throw it, the y-intercept will be 2 because that's its initial starting point of when it starts to go up into the air, right? Let me erase this because this looks very bad. So if I do this better, okay, that looks a little better. So if I do this, right? We know it starts here, goes, and then it's gonna somehow, not somehow, it's gonna at some point hit the ground. Pretend this is your ground, right? Pretend that's your ground, what I just highlighted. How can we figure out when the ball touches the ground? Well, we know the ground is 0 as the x value, right? And we also know the ground has 0 height. When something's on the ground, there's no y value, it's 0, right? Because there's no height. There's just no height. You see the ball, it's not even here. Because if it was here, then there will be some height, right? If it was here, there would be some height, right? If it was here, there would be some height. But no, we're talking about the ground hitting it right on the x-axis. There's going to be 0 height. So that means in this equation right here, we can actually set h equal to 0 and then rewrite it out again. Because remember, height's just 0 when it's on the ground. t plus 2. And now what can we do? We can either factor it, right? Because when we factor, we solve for the x-intercept. And that's kind of what we're solving for. We're figuring out what the time will be, right, when it touches the ground. After how long will it touch the ground, right? And so to isolate for t or solve for t, we have to use the quadratic formula or factor it. So in this case, I don't think it can be factorable. So I'm just going to use the good old quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. And let me quickly plug in all the values. Hi guys, so I'm back. So after doing the quadratic formula, I got 2 answers because obviously, when using the quadratic formula and when factoring, you're going to get 2 answers. And 2 answers can work because think about it. If the height, for example, is 8 meters, we want to find out the time after 8 meters, right? There can be 2 answers because the ball can reach this same height at 2 different times, right? But sometimes they don't work. And here, I'll show you why. So I got 2 answers, and the right answer is t equals 3.13 seconds, right? Around. And the reason this answer is not right, the reason this answer would not work in this case is because, look carefully, there is a negative sign. And can time ever be negative? In reality, no. Right? Time just keeps going and going, but it can never be negative. So, therefore, this value with the negative is not a solution, but this value here, t equals 3.13 seconds, is a solution. So if we write a therefore statement, therefore 3.13, my bad, seconds. And that's it for that question. Now, if we go to the next question, it's a little different style. There's many different styles of quadratic applications, but this one's not that bad. So a rectangle length is 3 centimeters longer than its width. The diagonal is 15 centimeters. Determine the dimensions of the rectangle. Let me add that E of the rectangle. So what we know is that the rectangle length is 3 centimeters longer than the width. So we know the length is right here, right? I can't write cursive. I'll just write this as length. This is the length, and we know this is the width, right? In other words, we can also say, since the length is 3 times longer than the width, right? We know the width is a X amount or a Y amount, whatever variable you choose, but we don't know the width, right? But we do know, also the length in comparison to the width, because we know the length is going to be 3 centimeters longer. So it's going to be than the width. So 3 centimeters longer than the width. So 3 plus X, right? So now what do we do with this information? This one also takes a little bit of imagination. What could you possibly use to help us in this situation, right? If you look at this closely, right? If you look here, the reason they gave us a diagonal is because it gives us a triangle, right? And we know that this length here, right? Because the length, these two sides are the same, and these two sides are the same. So these will have the same lengths, right? But we know that if we draw a second triangle, what I've highlighted, if this is the length of the triangle and this is the width, right? And we know those values are 3 plus X and X, and we're given the diagonal is here, then what can we use to help us? Well, we can actually use Pythagorean theorem. And that might seem a little crazy, but look. So ax squared plus, whoa, no, I'm thinking of quadratic, like the quadratic equation. Wait, my bad. A squared plus b squared equals c squared, right? So in this case, we'll do our length squared plus our width squared equals our diagonal, which is 15, right? Because if we were to label this triangle, it'd be A, B, C. But if we do use the Pythagorean theorem, right, and it's length squared plus w squared, width squared, then it'll be 3 plus x squared plus x squared, my bad, squared equals 15 squared. So if we evaluate this, we are going to be left with, so 3 plus x, because we have to simplify this still, right? 3 plus x squared equals, what is 15 squared? 15 squared is 225. So it equals 225. So now let's use distributive property here in order to figure out these terms. So we're left with 9 and then plus 6x plus x squared. Yes, okay. Now we do plus x squared equals 225. So we are left with, because we still have to simplify everything, 9 plus 6x plus 2x squared. Because remember, x squared plus x squared, if we simplify that, we are left with 2x squared, then equals 225. Now, how can we further simplify this in order to solve for x, right? So what you have learned also is to collect like terms. So when we collect like terms, the only like terms we have in this equation are 9 and 225. So if we bring 225 on the left side, we are left with 9 minus 225. So then we're left with negative 216 plus 6x plus 2x squared equals, and then since we got rid of the 225 equals 0, right? Because nothing's on that side. And if we want to solve for x, we look at the power of the equation instead of the power of 2, meaning this is a quadratic. So if we put it into the y equals ax squared plus bx plus c form, we are going to be left with 2x squared plus 6x minus 216 equals 0. And we can probably factor this, and if we can't, I'm sorry, but I'll be wasting your time, but I think you can factor it. So we've looked at all the common terms. 2 is a common term, 3x, and then 216. It's going to be minus 108 equals 0. Okay, let us see now. I have to find two numbers that add to 3 but multiply to negative 108. So let me think. Let me use my calculator. Oh, I think I found something. No way. Would that work? Yeah, that would. Okay, so we have a negative, oh my bad, 12 plus negative 9 equals 3. 12 times negative 9 equals negative 108. So if we do factor it, let me quickly use decomposition. Actually, no, it's fine. I think we're just going to be left with x plus 12, x minus 9, right? Yeah, we're just left with those. Okay, so then now, if we set everything equal to 0, right? This will be 0, this will be x plus 12 equals 0, so x equals negative 12, and then this will be x minus 9 equals 0, so then x equals 9. Now, it wants us to figure out the dimensions of this triangle. So again, we have to use some of our common sense, and you'd probably have to write this on a test. Again, both values could work in some cases, but in this case, one value will only work. And the reason the only value that will work is x equals 9 is because x equals negative 12 is because it's negative, right? Can you have a negative side length? No. So you have to use, again, like a little bit of common sense here, because you cannot have a negative side length. So x would be your right answer. So that means the width will equal 9 and the length will equal 12, because we have 3 plus x as the length, right? And that's basically it for that question. For the next question, this one's a little bit more complex, might take a little longer, right? I hate these questions, me personally. Once you get the hang of them, they're not that bad, but these styles are weird. So the next question is, a sporting goods store sells 90 ski jackets in a season for $200 each. Each $10 decrease in the price would result in 5 more jackets being sold. Find the number of jackets sold and the selling price to give revenue of $17,600 from sales to ski jackets. So there's a lot going on in this question. So let's break up what is happening. So a season, we have to make an equation here. So it says a season, they sell 90 ski jackets in a season for $200. Okay. And what we're going to want to do first is make an equation, right? Which can then help us figure out how many ski jackets are sold and the selling price that also gives this revenue, right? So we'll make an equation. This equation will turn out quadratic, right? And what we're going to want to do is make some variables. Let R equal revenue, and then let let me see, and then let X equal the decrease. And you'll see what I mean by decrease. The reason decrease is because look, it's going down. So every time they go $10 down in price, it would result in 5 more jackets being sold. So if you, for example, so if each are 200 originally, right, and if you minus 10, that means they'll get $190. And that means if it's $190, 5 more jackets would be sold. So if the sporting goods store sells 90 ski jackets in a season for 200 each, that means they will get 95 ski jackets, right? Because if you're reducing $10, you get 5 more. If you're reducing $20, you get 10 more, right? If you're reducing to $30, you get 15 more, right? So what we're going to want to do is make an equation, make one bracket in the equation for number of jackets sold, right? That's going to be one bracket. And then the other one will be number, or not number, but price change, for example. Price change. So we know that they start to sell 90 ski jackets in season for 200 each. So if we make the two brackets, so we know they sell 90 ski jackets, and we know for 200 each, right? So if one bracket is number of jackets sold, how is that being affected? Well, that's being affected if the price goes down by 10 each time, right? Because if it goes 10 each time, you're gonna add 5 more. So it's going to be plus 5, but not just 5, 5x. And the reason x is because decrease in price. Decrease in price or change in price. So the reason we add the x is because, remember, like I said, if it's going down one time, right, then they're going to add 5 more jackets. But if the price goes down twice as much, it's going to be 10 jackets because this x will be 2, right? If the price goes down if it goes $30 down, then they're going to get 15 more jackets sold, because for every $10 decrease, they get 5 more jackets. So remember, and the price change, if it goes minus $10 then we have to add the x again, because then it shows the change, because it depends how many times you decrease the price, right? And so if x is 2 here and x is 2 here, 200 minus 10, say the price change now will be $180. So for $180, how will that affect the number of jackets sold? Well, 2's there, 90 plus 5 times 2, that is 10. So that means it's going to be 100 jackets sold. So if the price is 180, there will be 100 jackets sold, right? Now, I hope that made sense to you, and I hope you grasp that. But maybe if I talk more and go more in depth on why we do some of it, then it should make more sense. So now it says, find the number of jackets sold and the selling price that gives a revenue of $17,600. So find So find a value for X, right? Because that's what's changing. That will give us a revenue, because R equals revenue of $17,600, and will be like this, right? So what value of X will make us have a revenue of that much, right? But before we even do anything, let's expand this out by using distributive property. Let's expand this out because it'll make it much easier to work with as we'll get a quadratic. Um, so now, again, what do we do to isolate for x or solve for x, right? Factor it or use quadratic formula. So then I'll factor it because they can all be divisible by 50. So with x squared minus 2x, 50, 100, 150, 200. So then that one will be minus 8. Should be. I cannot do mental math. It should be that. Yeah, okay, good. Um, that's about it. Now again, we look at two numbers that add to -2 but multiply to -8. Let me think off the top of my head. -4 and +2. So we're left with this. X -4 and positive x minus 4 x plus 2. Again, if you want, I'm skipping steps for factoring, but if you don't know how to factor, you should just be, once you factor using whatever method, decomposition or cross method, right, you should be left with this answer, x minus 4 x plus 2. So now this will be 0, x minus 4 equals 0, x equals 4, x plus 2 equals 0, x equals -2, right? And again, you have to reason it out. Why can't it be -2? Because can change be -2? Like if I put -2 in the price change, right? That'll be 200 minus 10 times -2. 10 times -2 is -20. So in fact, if this is negative, if we input x minus 2 into that, we are going to be left with a loss. We are increasing the price and we are losing the amount of jackets being sold, right? But the value here that's important is x equals 4. We are going to input that value 4 into this right here where we created the number of jackets being sold, and then the price change, right? We're going to input it in there as x, and that will give us the answer of number of jackets sold and the selling price, which gives us a revenue of 17,600, right? So if we substitute in 4, right, and not -2, because there's a value, the -2, like, again, it doesn't reason out if we use -2. And so now, since they want specifically the number of jackets sold and the selling price, that gives a revenue of 17,600. We have to substitute in 4 into this formula that we created because that will tell us the number of jackets sold, and into this formula also because it'll tell us the price at which they are sold. So that means to get a revenue of one 110 ski jackets. And then that's your answer for that question. And yeah, that's basically it. These questions tend to be a little long depending on what they ask for. This one they wanted us to do an extra step, and that is to actually input the 4 we get, right? Because that 4 is when the revenue is 17,600, right? right? So that's the extra step we had to do with finding how many ski jackets and what the price would be to get a revenue of 17,600. And that's that question. The next question you can do on your own. You can pause here and then I'll solve it right now. So see you guys in a bit. Oh, I just realized I forgot to say I forgot to said what to determine. So in this question, I want you to um determine when the water balloon hits the and then ground. And yeah, that's what you have to determine for this question. Now let me actually solve it. I have finished the answer, and that's basically it for today's lesson. I hope you got this right. If you ever want more questions about what's it called, quadratic application, I can always do some more examples or send you some. And yeah, that's basically it. I hope you all enjoyed today's video. Please like, subscribe, and share. And I hope you have a I hope you have an awesome rest of your day, night, evening, or whatever time it is for you. Good night, everyone. Or goodbye, not good night.